Average speed and average velocity describe the same trip in two different ways. Average speed uses distance. It equals delta s divided by delta t. Average velocity uses displacement. It equals delta x divided by delta t. The formulas look similar because both compare a change in space with the same elapsed time. The difference is in the numerator. Average speed uses the complete length of the actual path. Average velocity uses only the change from the initial position to the final position. So when do average speed and the magnitude of average velocity have the same value? Because we are describing the same motion over the same positive time interval, the denominators are equal. The two results can have the same magnitude only when the distance equals the magnitude of displacement. Imagine a person walking 10 meters directly to the right without turning back. The distance is 10 meters. The magnitude of displacement is also 10 meters, because the final position is 10 meters from the initial position. If the trip takes 5 seconds, the average speed is 10 meters divided by 5 seconds, which equals 2 meters per second. The magnitude of average velocity is also 10 meters divided by 5 seconds, which equals 2 meters per second. The values are equal because the actual path lies exactly on the straight displacement segment from the initial position to the final position. There is no turn, no detour, and no motion back toward the start. Now change the motion. The person walks 10 meters to the right and then 4 meters back to the left. The distance is 10 meters plus 4 meters, which equals 14 meters. But the person finishes only 6 meters to the right of the start, so the magnitude of displacement is 6 meters. If the complete trip takes 7 seconds, the average speed is 14 meters divided by 7 seconds, which equals 2 meters per second. The magnitude of average velocity is 6 meters divided by 7 seconds, or about 0.86 meters per second. The values are not equal. This example reveals an important trap. Straight line motion by itself is not enough. An object can remain on one straight line and still reverse direction. The return motion adds distance while reducing the separation between the initial and final positions. The complete condition is more precise. Average speed and the magnitude of average velocity are equal when the object moves along a straight line without reversing direction. In other words, the object must progress directly from its initial position toward its final position, with no turn and no backtracking. If the path bends, the actual route is longer than the straight displacement segment. If the object turns back, it adds more distance without moving the final position farther from the start. If it completes a loop and returns to the initial position, the distance can be large while the displacement is 0. This gives us a general inequality. The magnitude of displacement is always less than or equal to distance. Dividing both sides by the same positive elapsed time gives a second inequality. The magnitude of average velocity is always less than or equal to average speed. The reason is geometric. Displacement gives the shortest straight connection between the initial and final positions. Distance measures the actual route. An actual route cannot be shorter than that straight connection. Consider one final example. A person walks 100 meters from home to a store and then walks 100 meters back home. The distance is 200 meters, but the displacement is 0 because the initial and final positions coincide. If the trip takes 100 seconds, the average speed is 2 meters per second, while the average velocity is 0 meters per second. The person certainly moved, but there was no overall change in position. Physically, average speed and average velocity have the same magnitude only when the actual path is exactly the straight displacement segment from start to finish. Any turn, detour, or backtracking makes the distance larger and makes the magnitude of average velocity smaller than the average speed. If this explanation helped, please like the video, subscribe to the channel, and leave your physics question in the comments. We will do our best to answer it.